And away we go. Here we are. Assignment 3G. 3G is the assignment. We have one bonus question today, I guess. All right. And so what this is derivatives of trig functions, and kind of looking forward through this, we need to know also the product rule and the quotient rule. So again, let's review one more time. The product rule is where we multiply things. So if I have u times v, okay, the derivative of that would be u prime v plus the same thing, but the derivative of the other. So u v prime, okay, where the prime is the derivative of that specific thing. And then if I have u divided by v, that implies that the derivative is bottoms up. So v goes up, u, and then it's pretty much the same thing as, oops, excuse me, that's your word, sorry. It's the same thing as the product rule, but it's a minus, and then it's a derivative of the other, so it would be like v, so v prime u, so it's just the derivative of the other. So first it was the derivative of the u, then it was the derivative of the v, all over the bottom squared. Okay, so it is a mixture of these rules, as well as what we learned last time is the derivative of sine goes to cosine. Should actually say like goes to implies. They're not equal to each other. It implies. And then cosine goes to a negative sine. Okay, as well as the normal exponent rules and you know, the how to take derivatives of things in general. Again, real quickly, the derivative of x is equal to 1. That's sort of like e to the x is equal to x. All right. So first problem is use the product rule, because this is a multiplication and find the derivative. So this is u, this is v. So this is multiplying. So e to the x and cosine of x. So the derivative is going to be u prime v plus v prime u. Okay, u prime v plus v prime u. So I take the derivative of 1, leave the other alone, and then I add the opposite of what I just did. Okay, so the derivative, I'm going to take the derivative of e to the x. The derivative of e to the x is e to the x. Then I don't touch the other. Okay, so I took the derivative of, in essence, that one, plus, now I go back to the same problem and I take the derivative of the other. So in that case, the cosine. So e to the x is just left alone, and the derivative of cosine is negative sine. So that's the sine, and then this would be the negative sine. Negative sine. All right, use the quotient rule in here. So this is u divided by v. So this is going to turn into bottoms up. It's going to be bottoms up, derivative minus opposite, all over the bottom squared. So here we go. The derivative, bottoms up, that means e to the x comes to the top. Derivative of the top minus, okay, the derivative of the bottom, and leaving the top alone. All over the bottom squared. And so cleaning this up just a little bit, ooh, I know what I can do. Okay. This is probably what, if you look up the answer in the answer key, this is probably what it says. This, you're technically able to GCF out at e to the x, which will leave a cosine x minus sine x. Okay, so I just GCF'd out an e to the x. And this is an e to the 2x, or aka e to the x squared. But what you get to do is you get to eliminate one of these e to the x's with one of these e to the x's. Okay, it might be a little bit better to understand this. Yes. So if I have e to the x squared, it just leaves one of the e to the x's. And so this will ultimately be cosine x minus sine x all over e to the x. So it turns into. Finding and evaluating the derivative. So here, ultimately, what we're going to find is the f prime of c, which means I'm taking the derivative at a point. So to take a derivative at a point, what you first need to begin with is the derivative. So I find the derivative. So here we go. What is the derivative? So I take the derivative of x, which is 1. So 1 times cosine, plus leave the first alone and take the derivative of the second. So this is an addition, but I'm going to change it here. So cosine goes to negative sine. And so that'll be a negative sign. The plus turns into a minus. All right, so that's the derivative. Now, how do I take the derivative at a point? Here they have c being pi over 4. So in essence, what I'm seeing is cosine of pi over 4 minus pi over 4 sine of pi over 4. So here we are using a little bit of trigonometry, focusing around the term pi over 4, which is square root 2 over 2. Okay, for both the sine and the cosine. So this is square root 2 over 2 minus pi over 4 times, I'll put it in parentheses, root 2 over 2. Now, I don't know if they want you to put that together or not. I'm not exactly sure, but if they do, it would look something like that. Square root 2 over 2 minus root 2, it would be pi root 2 technically is the correct order. Pi root 2 over 8. I think something along that line is the correct answer. I don't think they're expecting you to put the the numerator together. It'd be 4 root 2 minus pi root 2 all over 8 in that case. I don't think so. I think this is what the answer is expected to be. Okay, find the derivative of the transcendental function. Okay, I'm not quite sure what a transcendental function is, but I can take the derivative of this. So the derivative, so this is a multiplication, so it's ft to the squared times sine t. So the first derivative will be of that t squared, so that's 2t. Leave the second alone. Plus, okay, now I'm taking the derivative of the second, so that'll be t squared, so I'm not touching that, and then that'll just be cosine t. Okay, here we have a quotient rule. So the derivative is going to be bottoms up. So t comes up, derivative of the top, which is going to be, so bottoms up, and the derivative is going to be negative sine. So this is going to be sine negative, so that's a negative sine. And that's going to be minus, okay? So there I took the derivative of the top. Now I'm going to have to take the derivative of the bottom. So the derivative of the bottom is 1. Leave the top alone. Oops. So as I was saying, this is minus, derivative of the bottom is 1, and then leave the top alone. all over the bottom square. Okay, maybe I lied a little bit. Maybe you do need to know some derivatives of other things here a little bit. Let me just take a quick glance here. All right. Brief little mini lesson here. Tangent goes to secant squared. Okay, tangent goes to secant squared. So the derivative of tangent is secant squared. Let's go with secant. This is the next logical step. Secant is equal to secant. That's easy. Tangent. Okay, so again, secant goes to secant, tangent. Tangent goes to secant squared. Secant goes to secant, tangent. Yeah. So that's pretty much what you need to know. Now, alternatives of this is, as I was kind of alluding to, codes are equal to negative. So for instance, cotangent, okay, is very similar to this, dude. Okay, cotangent is going to be equal to cosecant. So cosecant squared. However, it's negative. And cosecant is equal to cosecant cotangent. But it's negative. So it's just the basic idea. If you take a derivative of a co something, the answer is going to be negative. And tangents work with secants, and then cos deal with cos. All right, sorry, back to here. So here we go, derivative. E to the x is e to the x, so that doesn't change. And then tangent goes to secant squared. Okay, before this one, again, I'm going to rewrite the goofy stuff. All right, it helps me take my derivatives just a little bit easier. So here my derivative is going to be the 1/4 drops minus 1, so that would yield a negative 3/4. Cosecant is going to be cosecant cotangent with a negative. So this is going to be a minus 6 cosecant cotangent. I'm not going to worry about cleaning up that t to the negative 3/4. That'd be the only thing that you would maybe need to clean up, but I think it's good enough. All right, cosecant is cosecant cotangent, negative, so that negative turns into a positive. So this will be a positive cosecant cotangent. And then sine goes to cosine, so that negative still remains negative. Okay, here we have the product rule. So we take the derivative of that x squared, leave the second alone, and then this is going to be plus, and I'm going to just start a new line, derivative of tangent, actually no, I can take care of it right here, no. So the derivative of the first, leave the second alone, leave the first alone, take the derivative of the second, and that's going to be secant squared. Find the second derivative. So the second derivative begins with the first derivative. This is a multiplication. So I take the derivative of the first, that's the x. So x goes to 1. So leave the second alone, plus leave the first alone and take the derivative of the second, which is going to be cosine. All right, now the second derivative. This is where it's going to get crazy. So sine is cosine. Now, here in this, we have to recognize that this is a product rule. So this is very similar to the original problem. All right, so this is going to be plus, and now let's do the product rule. So the derivative of x is 1. So plus, I'll write it down here, plus, leave the first alone, the derivative of the second. So a derivative of the first, and then derivative of the second. So cosine is going to be negative sine. So if you really think about it, this would be 2 cosine x minus x sine x. Y is equal to bleh, and dy dx is equal to whatever. All right, so I'm going to recognize that as the break right there. Actually, I'll think of it like this. Think of it like that. So 4 is going to be chilling. And so here we go, the product rule. The derivative of e to the x. Leave the second alone. Plus, leave the first alone, derivative of the second, so that's the cotangent, and so that's going to be cosecant squared, but it's negative, so it's negative. So something in essence that says that. Oh, okay, I see what they're doing. Notice that how you can GCF out and e to the x from both sides. So this could be 4e to the x cotangent minus cosecant squared. I think that would probably be it. Boom. Okay, using the definition of a derivative, blah, blah, blah. Find the dy dx if y is equal to that. So I think they just want us to do it old school stuff. They just want us to do it old school stuff. All right, so I don't know about this delta x kind of thing. I get it, but I'm not going to use that. I'm going to use the h version. So the limit as h goes to 0 of f of x plus h. So that'd be negative 2x plus h squared plus 1 minus f of x. So that's negative 2x squared plus 1 all over h. All right, so I'm going to kind of jump ahead. We're taking the derivative, but we're taking the derivative in this like old school style. I can see real quickly that the answer is going to be negative 4x. Just like knowing how to take derivatives, we can take the derivative. However, they want you to do the math. They want you to show that this formula truly works and is how you technically are taking a derivative. We're just using this, like this almost cheating method of doing it. Right, so technically, this is the cheating version of doing all of this math. So here we go. Let's do all the math. So negative 2x squared plus 2xh plus h squared plus 1 plus 2x squared minus 1. I'm just going to keep this in this own thing here real quick. All over h. So I'm going to distribute in that negative 2, so the limit as h goes to 0 of negative 2x squared minus 4xh minus 2h squared plus 1 plus 2x squared minus 1 all over h. So let's eliminate. So negative 1, positive 1. Positive 2x squared, negative 2x squared. Everything else has an h in it. So h, h, h. So that leaves us with the limit as h goes to 0 of negative 4x minus 2h. So if h goes to 0, this is equal to negative 4x. Which is exactly what the derivative should be. Just big algebra. I think that was the last problem.